Okay, hello, welcome back to my channel for YouTube account or for Instagram account. And today, for this chance, we have to try to solve again one of the problem from basic physics. Actually, this problem that we want to solve today is a problem for grade university, but I think again, it's possible to be a hot problem for senior high school students. So let's we check what case we want to solve today. Okay, we see in this screen there are one of problem that is I refers to one of physics books that authorized by John D. Cardinal, which is number 93, with the case a penguin slides at a constant velocity of 1.4 meter per second down an icy incline. Okay. The incline slopes above the horizontal at an angle of 6.9 degrees. At the bottom of the incline, the penguin slides onto a horizontal patch of ice. The coefficient of kinetic friction between the penguin and the ice is the same for the incline as for the horizontal patch. The question is, how much time is required for the penguin to slide to a halt after entering the horizontal patch of ice? Let's we try to solve this problem. Okay, to solve this case, I think it's better if we try to explain this case to an illustration. So the first step is let's make an illustration. Based on this case, we know, based on hint or clue, this is the penguin slides down an icy incline. So the illustration be like this. This is a initial position, and this is a position before the penguin slides onto a horizontal patch of ice. Let's say the initial position is A, and this is B, and the horizontal after B is a horizontal patch to C. And we know that the angle of the incline slope is 6.9 degrees. Okay, we write this 6.9 degrees, and we can draw, or we can say a penguin is like a point, that slides at constant velocity 1.4. This slides with velocity 1.4 meter per second in units. And we have the other hint or the other clue, which is the coefficient of kinetic friction between the penguin and the ice along A to B is same for B to C. So we have mu k for coefficient of kinetic friction from AB is same or equal to mu k BC. We have this hint. And what's good? There is the other hints. I think this is the other hints. Wait, I have to change my highlight color like this. A constant velocity What's mean of constant velocity? V equal to constant. What means? This is means there there is no acceleration. There is no acceleration. So for this case, it means V in A or in point A, it's same to V in point B, like that. V at point A it's same with V at point B, and we know that for a thing or whatever that in position at incline or at slope, we have a diagram force like this. This is W or mg, weight of an object, and we have a normal force. Wait, I have to change my color again. We have the normal force like this, and we have a force that make an object move. For this case, we have to draw a diagram force to this direct. Let's say this is a fx. We got it. So we have one diagram force game, that is a friction force, which is direction is opposite to fx. Let's say like this. This is fk. So we have 1, 2, 3, 4. We have 4 components of force. If we write A, then because velocity is along A to B is constant, velocity is constant, so we know that for Fk equal to Fx. That is because velocity is constant along A to B. Or we can write this equation to be, for Fk is, we know, mu k times to normal force equals to Fx, that is mg sine of 6.9 degrees. Or we have divided all side, both of side, with mu k, so we got it normal force is equal to mg times to sine of 6.9 degrees divided by mu k. We can say this a force equation. So what's next? How much times from B to C, B to C. Based on this clue or this hint, we got it. I'm sorry, there is clue. This is how it can be stopped at C. So in this case, the problem is explained to us that the penguin will be stopped in C, like that. Okay, Based on equation of kinematics, we got it v equals to v equals to initial v if an object will be stopped. That means we use minus sign in this equation, and then we got a times t based on kinematic equation. If we connected this equation to this case, so we got it v in this equation would be 0, and v0 in this equation would be v on b, that is va. So we can write va minus a times t, or we can eliminate both sides with va or with a times t or whatever. I would eliminate both sides with va, so we got it va equals to a times t, or we can rewrite this equation to be t equals to va divided by a. So the next question is what is a? We can use this equation, the first equation, to find what is a. Based on Newton's second law, we know that we have an equation sigma f equals to m times a. Sigma f equals to m times a. And along b to c, we know that only any friction force that exists in an object. Let's we say this box is a penguin. Only a friction force that exists in this object. Let's say Fk. And for the vertical axis, we have mg, and we have normal force, like that. We have normal force. So we got it for sigma f. We can substitute to Fk, and equals to m times a, like this, which is, we know that Fk is equal to mu k times to normal force, and it would be equal to m times a. And we know, based on this picture, we know that mg equals to normal force. Okay, so we can write this equation to be mu k times to normal, oh I'm sorry, not normal force again. We can change normal force to mg. Mg equals to m times a. And let's we back to the first picture, the first illustration. In this illustration, actually we have a relation mg to normal force. So what is the relation of mg and normal force based on the first picture? Based on this picture, we can write the relation is mg is equal to normal force cosine of angle 6.9 degrees. 6.9 degrees. We can use this equation to solve what is A. We can write mu k times to mg, we substitute with n times to cosine of 6.9 degrees equals to m times a. And based on the first equation, we have mu k times to normal force that we substitute to be mg times to sine of 6.9 degrees divided by mu k times to cosine of 6.9 degrees equals to m times a. And we made to eliminate mu k and we made to eliminate m, so we have acceleration of penguin at horizontal pitch is equal to g times 2 sine of 6.9 degrees times 2 cosine 6.9 degrees. Or we can change this equation to be half times g sine of 13.8 degrees. This is an acceleration, and because t is equal to va divided by a, so we can rewrite this equation. T is equal to va divided by a is equal to va divided by half times g times sine of 13.8 degrees. Substitute this variable with value based on the problems, so this equation equals to 1.4 divided by half equals to g. In this case, I use value of g is equal to 9.81 and times to sine of 13.8 degrees. So we have the equation t is equal to 2.8 divided by 9.81 times 2 sine of 13.8 degrees. I'm sorry. Okay, so this is the answer of our problems today. So how much time is required for the penguin to slide to a halt after entering the horizontal patch of ice? The time is equal to 2.8 divided by 9.81 times sine of 13.8 degrees. I think enough for today, and I think you all can to try the other problems with the same concept with our problem today, and you have to try till you know how to solve the problem that you face on the exam. Maybe before I close this chance, I have to edit units in our answer. Unit of this is second. Units, don't be forget of units in physics. Okay, thanks for watching. See you and bye bye.